Okay, the next component in our logger is the Arduino board itself, and we use Pro Minis. You usually get them off of eBay, and unfortunately that involves making sure the thing works. So the first thing you do with one of these cheap clone boards is put some UART pins on it and test it out, because about 1 in 10 of them usually doesn't work very well. So they usually come with these 90-degree pin headers. I don't use those in our build, so you have to cut another length. It's a good idea to have some spare pins. You need 6 of them here for the UART connector. And what we're going to do is just solder those into place so we can test the board. And the way you put pins on just about any board is to have a scrap breadboard kicking around. Now once you do this, the breadboard itself is useless for electronics projects, so I always have sort of an old one that I use for nothing else but holding rows of pin headers in place on boards. So just as before, we're going to tack the corners first just to keep it in position. So I usually start with the farthest one. Again, hold the iron so there's enough heat, and give it, just push the solder in, and you want to push the solder in on the pad, not on the iron. It'll always melt when the iron is hot, but you want to make sure that you're not trying to solder to cold pins. See, on the pin to be warm, there we are. I just pull that away. And there's the next one in the row here. I'm just going to go to the far end. Again, I'm pushing the solder into the pad, not into the soldering iron, because once the pad's hot enough, everything should bond properly. There we are. So now I've got the pin header sort of aligned. It doesn't look too crooked. I can go and do the rest of them. Just quickly finish that off.
It's a bit Goldilocks. You want to have enough heat on there that the solder is flowing down around the pin, but not enough to melt the plastic of the header pins.
Yeah.
But this is a fairly metal heavy. The header pins have a lot of metal in them because those pins are awfully long. This is probably less heat required than for the screw terminal boards, but more than what's needed for the sidecar pins on the screw terminal board.
Yeah. And there's always excess flux there, which we'll go and clean up once we're doing the rest of the board. But the first thing to do, as I said, get your UART connector in place, because of the failure rate you'll see with these cheap clones off of eBay. I'd say about 1 in 10 of them's a dud. And you want to know that before you go any farther. So we just put our UART board onto the board, and then I usually use the blink sketch. And the blink sketch will trigger on this board the pin 13 LED. So there's a little LED here. You load the blink sketch, and it will it'll fire that off once a second, and then you know that your board's good, the comms are good. There isn't sort of a short circuit somewhere in the way they did the reflow on the board. So once you've got the test done, and I'm just going to go ahead here assuming that this board is good, which is an unknown, and I'll flick those limit resistors off. Once you've tested, you know that the board's good, you can just find the limit resistor associated with each of the indicator LEDs. This is the pin 13 LED, and I'm just holding my iron on it, and it flicked off and came off right on the iron. Shake that off my iron here. There's another power wasting LED here on this board right next to the voltage regulator, and it's on all the time, which is a complete waste for data logging applications. So again, apply the iron to the side of the resistor.
How hard are you pushing on the soldering?
Gently. And it lifted halfway here. So what we have is the resistor, they call that tombstoning, when only half of a component is on the board. And so I have to go in and pick the rest of the resistor off. And you want to be careful when you pull that off, you're pulling towards where the component was, because if you pull it away, you could end up with this spaghetti string of circuitry that you lift up with it, and you don't want to hurt the rest of the board, so pull that towards you. So we've removed the pin 13 indicator LED and the power indicator LED, and the next component we're going to remove is this reset switch, because the SD card board is going to sit right on that location, and so we don't want it hitting the reset switch. So you basically just dig the clippers into the one side very gently, you do a little clip, and you should be able to lift that switch and just rock it back and forth.
The metal fatigue will just break that
Yep.
connection.
Yeah.
And that's now garbage.
Yeah, that switch could be used somewhere else, but we don't really need it for the loggers. Okay, so that's our first stage of preparing this board. And the next one is to add some riser wires to the A4 and A5. These two analog connections actually get repurposed in our logger as the I2C bus. So we have to pull them away before we attach all of the pins. And that's easier to do if you move it onto a pair of helping hands or a clamp. These are the Panavice Juniors. They're my favorite for doing this kind of work because there's a little clip here that you can move around. Okay, and when you're trying to put wires into a board, in this case we want our wires coming out the bottom, and so we have to have sort of another little helper. First one holds the board in place, and then the second helper holds the wires while I give them a little touch of solder. Alright, so this is a little snake with a clip on the end, and so when I'm ready I'll just be holding the wire with this, and the board will be held in this Panavice. Before I do any of that connections, you need to strip and tin a little length on the end of these two wires. I always use white wires for the data and yellow for the clock, and that I do that for all the different buses, so it doesn't really matter what you use as long as you're consistent. Again, just a pinhead's worth. You don't want to leave too much flux on the wire or it won't go through the hole. So there's one. And there's two. So we've got our two wires tinned and ready. And you have to sort of flip the board over to make sure you're getting the right wire in the right connection.
So the extra clip is just to give it some upwards push.
Yeah, the wire has to be pushed up into the board, otherwise it'll just fall out as soon as you get the solder on it. And this is probably the trickiest soldering of the whole build, because you have to start with a clean iron. So give your iron a little scrub, and then as just as before, you sort of want to heat the whole thing all at once. So the pad and the wire. So there we are. I've got it heated, and I just pull away. And if you get the shape just sort of right, you get a little mini Hershey's Kiss there. And
but you're also right up against the legs of the IC chip.
Yes, that's the trick of
so
this.
So it's a tight space.
This is a very tight connection to be making. So now we're going to reproduce that with a yellow wire for the A5 connection. And again, it's a little tricky. You have to kind of hold the whole thing in place, route it through. Okay. While you're holding it with your fingers, bring in your helping hands and clip the wire from below just to provide enough pressure from below. Okay, and now we'll do the A5 connector, and again you need to have a really clean iron because this is a tight solder point. It's probably my least favorite thing about the Pro Mini boards is that these two connections are so awkwardly located. So there's the I2C bus extended. Those wires are coming out the bottom, and we're going to route them around to some extra pins that we're going to add to this board over here later. But for now, we've just taken them away from the pin headers we're going to attach.
If when you do this, if for example the wire sinks down a little bit and you have a gap on the underside of the board between the wire and the insulation, do you remelt it and then push the wire back up again?
Well, we can do that. The white wire's not quite perfect here. It's close enough actually, but just for the purposes of demonstration, let's do that. Once it's in place, you can kind of apply heat at the end of the wire, and it'll run down the wire, and then you can sort of reposition. So I'm going to grab the insulation on the white wire here, and I'm just going to remelt it from the top down, and it will get soft, and then I can, I can sort of move it around and reposition it, and then pull. You want to pull that solder away. So I was able to reposition that just by remelting it, by letting the heat flow down the wire itself.
Yeah, but then you want to hold it solidly in place so that it's not moving when the solder solidifies.
Yeah, but that happens fairly quickly. Usually I just push the insulation right against the bottom of the Pro Mini board, and that's enough. Okay, so we'll give this a little trim here now, and just get rid of the excess. Okay, so we've basically got the.
Do you trim them right down to the board, or do you leave the Hershey kit?
It's up to you. I usually trim them right down to the board. Again, because we're putting other things on top of this later. I usually trim them flush, but I only do that when I'm confident that it's a nice looking solder joint. Okay, and I've got everything in place. Alright, so the next thing we're going to do to the Arduino board is we're going to attach all the header pins, but we're going to do this in a slightly funky way, a little different than usual, because we're going to be repurposing some of those pins. Remember I mentioned that we're going to reuse the reset pins, so that means we're not actually going to use the reset pins. We're not going to connect them to headers. And we're also going to add some extra ones at the end as well. Okay, so on the one side, we want about 3 extra pins, because we've got this A7, A6, and ground connector back here, and I want to jumper them across to some extra header pins. So we're going to lay out one side of the board with 3 extra pins, and these 2 wires are going to get brought to some header pins as well. So we're going to need some extra pins coming off of the back side, the non-UART side of the Arduino board. So when we lay this out, we have to leave a gap where the reset pin is, because we're not connecting reset. Remember, on the screw terminal board we've already jumpered ground and reset on the one side, and we've jumpered VCC and reset on the other side. So we kind of have to make sure those pins aren't there. So we usually start with just cutting a couple of 2s, and you have to sort of do this by eye, or you can just lay them in. Okay, and so the start of the board, you want to make sure those are straight, and I didn't do that. They weren't straight, so let's try them again. So we just line them up. Okay, so those are in the right position. So that's the TX and RX pins on one side, and the 2 raw input pins on this side, and then the next one is the reset pins. We're going to skip those, and so we will need, I don't usually even measure this, I usually just stick them on there. But skipping the reset pin, we need 3 more here. 1, 2, 3 on the analog side. Okay, so there's 3 extras on that side. Plug them down. And on the other side, we're going to be pinning from the ground pin plus 2 extras.
Is there any advantage to not just doing it as a straight row of pins? Do you need that space?
You need the space. You don't want to bring the reset pin down. Okay, so there's the pin headers we're going to be using, and now I can just set the Arduino board on top. I should say Pro Mini board. And in this case, it's actually just a Pro Mini clone. And if the positioning's right, there we are. We should be able to get it nicely into place. So we will again be doing exactly the same trick we've done before, which is opposite diagonal corners, just to tack everything down. The first one's quite tricky because we now have the wires sort of pushing the board up. I'm going to have to apply some pressure with the soldering iron for that first tack. Let it in place, push the whole board down with my finger, and then lift the soldering iron so that corner's been tacked. Now I have to go around to the other side, do the opposite diagonal. Again, pushing it down, lift it up. I was waiting for the smoke to disappear there, which means we burned most of our solder off. There's the next diagonal.
You're burning the flux off.
The flux off, yeah, sorry. Okay, so there's 1, 2, and there's only one more missing. Okay. Generally, once you get those 4 in place, everything's held down, and so I'm just going to quickly work through, keeping in mind that there's no pin here under our reset here, and there's no pin under the reset pin here on the board. So that's because we've repurposed those. So I'm just going to quickly work through this. Alright, so once we're at this point, I'm going to add a little bit of tin to the end of these little sidecar pins, and because they're not surrounded by sort of the circle of solder that the ones going into the board are, I do add just a touch of flux to these before soldering them, just so that I can make sure that they will take.
These are pretty much the only pins you use flux on.
Yeah, it's you try and avoid it because you always end up with too much. There's flux built into the solder wire normally, and that's usually enough, but I find that these are a little bit trickier. They don't always take the solder. It depends on how old the pins are too. So now I'll just add some.
Do you find that different batches of components when ordered in, sometimes they're dirtier than others?
Always. You never know what you're going to get.
So if you think your components are dirty and are not taking solder, they probably are dirty.
Yes. Yep. Okay, so we've tinned those extra sidecars, and I'll add just a little touch of flux here. You can kind of, after a while, you can kind of see if the solder flows, then it's probably making a decent join. If it doesn't really want to flow, if it acts like there's some sort of resistance there to it moving around the surface, then there's a good chance that you don't have a good bond. You haven't really managed to get a nice layer of solder onto your pin. Okay, so those, now I've basically pre-tinned those pins, and now we're going to extend these 3 extra connectors, A7, A6, and ground, and we're just going to run them at 45 degrees out to that set of pins. Once again, I'm going to use the leg of a resistor just because it's a convenient source of wire. It's probably the most expensive way to do this, but it works because it has the right amount of stiffness. So I will just tin up the ends of this resistor. That's one side. Usually it takes about one resistor to attach those extra pins. And again, I'm just using it as a wire, not even as a resistor, so it's kind of wasteful. But now the first step is to just get the resistor in place. On the back side of that board. So here we are, I'll just tack it in. And while I'm doing this, I should give credit where it's due. This method of adding the extra pins on the back was developed by Brian Davis, who also builds loggers to put in caves. So he didn't like the way I was bringing the wires under the board in the original instructions from some of the other loggers, and he suggested this, and after I tried it a few times I realized that, yeah, this really is a nicer way to do it, to bring the connections down to the screw terminal board. And so I've just bent this wire so it's in contact with the pin that I'm trying to connect with, and I'll just melt some solder. Remember, both the wire and the pin already have solder on them, so this works really well because everything's already been pre-tinned. So that's the first connection. That's A7's been brought to that pin. And I'll just crop that. Crop away the excess here. And do it again for the next one. Okay, so there's the A6 pin.
So those are the two shorter ones, so you can usually get both of those off of one leg of the resistor.
Yeah, it depends on which resistors you have. All of these components have basically little to no standardization when you get them on eBay. So I don't like to say, oh yeah, you can always do this, because you never know. Alright, so there's our next connection, and again, just trim away the excess. Okay, A6, A7, next one is ground. I'll just use the other leg here. Sometimes it pops out. Yeah, you want to try and do these as cleanly as you can. Again, that's why I use a resistor leg, is that it has the stiffness to make this job pretty easy. So now we're going to bring these two wires over to those two excess pins. That's the I2C bus. We don't have to do the third one because we ran that extra rail line under the board, so the last pin on the screw terminal shield will actually be a 3.3 volt tap. Alright, so now we're going to bring these two I2C bus lines over. The A5 is the clock line. It gets attached closest to the Pro Mini board, and then the data line, the A4, gets attached to the next pin. And this is a little tricky. Again, you want to try and trim it so that you don't have a whole lot of excess. Usually I use about 4 or 5 millimeters and then trim away the extra. But cropping here is a little tricky. If in doubt, leave yourself some extra. And so I'm just going to strip about 4 millimeters there. Twist and tin the wire. And you'll need some tweezers to do this. bend if you can. Because they're both already tin, you should be able to just hold it in place and then let it cool.
And you had a ball of solder on the end of your iron as well.
Yeah, there was a little bit of solder there. So that's the first one. Again, I've done this a few times, so I tend to crop it pretty tight, but when in doubt, there's lots of room under the board in the final build, so you can give yourself a little slack.
Oh, that looks good.
Yeah, give it a little tug, make sure it's nice and secure. Okay, so now we've got all of the pins broken out so that we can attach them on the screw terminal board. We've gotten rid of the excess LED indicators, which don't serve any purpose other than wasting power. We got rid of the reset switch. The last thing I usually do at this stage is to trim some of these pins down, because we're going to be putting another board on top of it later, and there's a risk of some of these things sort of touching down. But if you don't want to do that, if you're worried about breaking your connections here, you can just add extra tape for the stacking of the sandwich. Usually I try and just sort of clean things up a little.
You want to be wearing glasses when you do this, because it does send the pin pieces flying.
Yeah, so I've just moved those pins down to flush. Not so critical on this side because there's no contacts on the SD board, but I usually do it anyway just to make it a little prettier. And they go flying everywhere, as you can hear.
And you're only cutting up to basically where the points of the IC chip are pointing to the sides of the board.
That's right, to the diagonal corners here, because the SD board will eventually sort of sit into that place. And then the last stage, of course, is cleaning and adding more, adding conformal coating. So let's give this a scrub, again, with the isopropyl.
Did you ever pre-clean your boards? Leading question.
No, not really, because I know I'm going to be messing them up. Whenever you do this kind of soldering, you're adding so much extra flux. I do pre-clean the RTC boards, but again, you have to be really careful. A lot of components don't like ultrasonic cleaning, which is the sort of standard way to do it. You give it an ultrasonic with some isopropyl. Oops, I pulled a little too hard on that pin and it came out. I'm just going to sing that back down. Made a little error there.
And it's not a concern to get the integrated circuit chips and all the components wet. They can get wet.
Yeah, I mean, in manufacturing, usually these things get bathed in water or alcohol or some soap solution. It's kind of one of the things that most people don't know is that electronics is usually waterproof. It's the short-circuiting of the power that causes problems, not the actual water exposure.
But of course you have to make sure that all of that liquid is off before you put the conformal coating on. Otherwise you've created a rust bucket.
Okay, and there's some little ends left here. I'm just going to trim those off. Those little guys need to be trimmed down as well. These are the ends of that resistor that we were using. My rule of thumb is if I've soldered it, it needs cleaning. Just clean anything that you've gone near with the soldering iron before you add the conformal coating. And again, you can see that's the two reset connections. We did not pin the reset connections. So they are not extended through, so those pins are available for repurposing as we did when we joined those pins on the screw terminal board. Alright, so reasonably clean. I think I probably could have done a better job, but for the purpose of this video we'll just take that and then dry them off. Again, 90% isopropyl is really nice. It tends to vanish quickly.
Of course, you're also holding it in your hand, so right now with the heat shrink, the hot air gun, you know, you're not overheating your components because it's in your hand.
Yes. I always use my hands as the safety system, which is sometimes not enjoyable. You make mistakes. Okay, next step is the conformal coating.
Best done in a fume hood if you have one in a laboratory or classroom setting.
Yeah, this is one of those things. If it was younger students, especially like high school students, I think I'd probably do this myself as the instructor. I wouldn't want to expose the youngins to this stuff. It is nasty. And again, the key thing is not to get the conformal coating on the pins extending below or above the board, because if you do that, you won't have any electrical connections. So you want to make sure these pins are nice and dry, otherwise you'll get flaky behavior. Alright, so now that needs to sit for at least 15 minutes. Usually I end up giving them an hour or so for that stuff to all dry, nice and hard, and then we can put tape on it. So that is essentially the Pro Mini component ready for the assembly stage.